All right, so now we're moving into 5.2. So we're sticking with the trig equations, but now we're introducing a couple different ones. So the first one we have is the cosine sum and difference, okay? Notice that we're basically taking two angles, right? We're taking an A angle and a B angle. If we were to add them together, okay, we wouldn't want to just add the angles together and then plug it into cosine. We have to take into account that they'll have different ratios, right? Because they'll be part of the same triangle. Okay, so if we know what the A and the B angles are, we could take the cosine of A, multiply it by the cosine of B, and notice that even though this is the sum, we're still subtracting, and then that would be minus the sine of A times the sine of B. So A and B are going to be two angles usually in the same, triangle. Okay, notice the difference. The cosine of A minus B looks similar, right? It's the cosine of A times the cosine of B, but this time it's plus. Okay, so those signs are changing. Okay, we also can think about our sine and cosine functions as co-functions of each other. If you remember back from chapter 4, the graphs looked very similar to each other. They were just slightly off, right? They were just, the cosine and the sine always were pi over 2 different from each other. Okay, so notice if we take pi over 2 and we subtract whatever our theta is, we're going to get sine. And the same thing with when we do that first sine, we're going to get cosine. So this is really just thinking about the graphs that there's just a phase shift or a horizontal shift. Pi over 2 away from each other. Right, we can just shift cosine pi over 2 either to the left or to the right, and it's going to match up with the other one. Okay. So then we also have the sum and difference identities for the sine function. Okay, so they're kind of similar to the cosine functions, right? We're still looking at a relationship between the sine and cosine ratios of these angles, okay? But in this sense, the sine, if we're adding the ratios. If we're subtracting the ratios, okay? So, and it's a little different in the other one. We had sine and sine together, cosine and cosine together. This one, they are flipped. Okay, so here's all of the equations all together, just nicely, neatly there. I will give you these equations on your assessment, so you don't have to memorize these. You're just going to have to figure out how to use them. Okay, so let's just talk about a little refresher back from geometry on how to find the sine, the cosine, and the tangent, just so that we're all on the same page, okay? So when we have a triangle, remember we can only use our trig ratios when we have a right triangle. So here's our right triangle. Let's call this triangle A, B, and C, okay? Across from capital A is little a, right? The opposite angle and side are, have a relationship. Okay, and then little c, little b, okay? And remember, all of this trig comes from our SOHCAHTOA. Okay, so you can think about these if you want to as opposite, adjacent, and hypotenuse still. Or we've also converted these into our unit circle and everything as our x, y, and r. Okay, so remember our sine of theta is our opposite over hypotenuse, or y over r. Our cosine is adjacent over hypotenuse, or x over r, depending on how the information is provided for you. And then our tangent is opposite over adjacent. I don't know why I just blanked on that for a second, or y over x, okay? So when you start these equations, it might give you a ratio of A or B. So it might give you like the cosine of A and the tangent of B. So it's going to give you enough information to at least have x, y, and or r, okay? Or you can think about it in terms of opposite, adjacent, or hypotenuse. So the first step you're going to have to make is you're going to have to find that missing piece, okay? So remember, these again are right triangles. So when we have right triangles, that opens the door for us to use our trig ratios. It also opens the door for Pythagorean theorem. So you can think about your Pythagorean theorem as your opposite squared plus your adjacent squared equals your hypotenuse squared, or x squared plus y squared equals r squared. But the first thing you're going to want to do when you get your function is you're going to have to find that missing piece, because you're going to need it to write one of the other ratios, right? If you're given the tangent, you don't have the hypotenuse, but you need that hypotenuse, right, in order to write your ratio of cosine and sine. Okay, so hopefully that's enough of an overlay. These equations are pretty much just find the missing piece that you don't have, write the ratios, plug and chug, and then you're going to simplify your fractions. Okay, just a quick thing, like remember when you have cosine of A, right, you're not going to plug in that ratio, right? Your cosine of A may be 3/4, and that's what you're going to put in your equation. Okay, and that is 5.2.